Assalamualaikum. My name is Farah Barudin, and inshallah I will present to you about one subtopic from chapter 4, aldehydes and ketone. So what we are gonna learn is the addition of hydrogen cyanide to aldehydes and ketone cyanohydrins. In this topic, we are going to learn the main three things, which are the first one is the reaction of aldehydes and ketone with hydrogen cyanide, and of course after that we are going to look at through its mechanism, and the last one is the synthetic application. As you can see, this is the general equation for the nucleophilic addition of hydrogen cyanide to aldehydes and ketone. So the product will be cyanohydrins. Cyanohydrin, also known as hydroxynitriles. So this is the reaction of aldehydes with hydrogen cyanide. Hydrogen cyanide acts across the carbon-oxygen double bond in aldehydes to produce compound known as hydroxynitriles. For example, this is ethanol, an aldehyde. So the product we will get 2-hydroxypropane nitrile. Next, this is the reaction of ketone with hydrogen cyanide. So as you can see, the product will be 2-hydroxy 2-methylpropane nitrile. For your information, the reaction isn't normally done using hydrogen cyanide itself because this is an extremely poisonous gas. Instead, the aldehyde or ketone is mixed with a solution of sodium or potassium cyanide in water to which a little sulfuric acid has been added. The pH of the solution is adjusted to 4 till 5 because this gives the fastest reaction. The solution will contain hydrogen cyanide from the reaction between the sodium or potassium cyanide and the sulfuric acid, but still contain some free cyanide ions. So this is very important for the mechanism. So let's proceed to the mechanism. Mechanism for the addition of hydrogen cyanide to aldehydes and ketone. I will give you separately, but there is absolutely no difference between them. So first, we look at through the mechanism of the addition of hydrogen cyanide to propanol. As we know, the addition of hydrogen cyanide to aldehydes and ketone is one of the examples for nucleophilic addition. So the carbon-oxygen double bond is likely highly polar, and the slightly positive carbon atom is attacked by the cyanide ion, and the cyanide ion is acting as a nucleophile. So let's proceed to the mechanism for the addition of hydrogen cyanide to propanol. The first step is as the cyanide ion approaches the slightly positive carbon atom, the lone pair of electrons is attracted towards the carbon and forms a bond with it. At the same time, the two electrons in one of the bonds joining the carbon to the oxygen are repelled until they end up entirely on the oxygen, giving it a negative charge. The negative ion form then picks up a hydrogen from a hydrogen cyanide molecule. Exactly as before, as the cyanide ion approaches the slightly positive carbon atom, the lone pair of electrons is attracted towards the carbon and forms a bond with it. At the same time, the two electrons in one of the bonds joining the carbon to the oxygen are repelled until they end up entirely in the oxygen, giving it a negative charge. The negative ion form then picks up a hydrogen from a hydrogen cyanide to form a molecule. Optical isomerism in 2-hydroxypropanitrile. When 2-hydroxypropanitrile is made in this last mechanism, it occurs as a racemic mixture, a 50-50 mixture of two optical isomers. Optical isomerism occurs in compounds which have 4 different groups attached to a single carbon bond. In this case, the product molecule contains a CH3, a CN, NH, and an OH, all attached to the central carbon atom. The reason for the formation of equal amounts of two isomers lies in the way the ethanol gets attacked. Ethanol is a planar molecule, and attacked by a cyanide ion will either be from above, the plane of the molecule or from below. There is an equal chance of either happening. Last but not least, we will proceed to synthetic application. Synthetic means a substance that made by chemical synthesis, especially to imitate a natural product. Cyanohydrins are formed from aldehydes and ketones and can be hydrolyzed to alpha hydroxy acids. For your information, alpha hydroxy acids or AHAs are a group of plant and animal derived acids used in variety skincare products. Cyanohydrin also can be converted to alpha beta unsaturated acid and beta amino alcohol. That's all from me. Thank you.